So for this question, the quadratic polynomial, can't speak, ax squared plus bx, a and b are constants, is denoted by f of x. So we've got in effect that f of x equals ax squared plus bx. Use differentiation from first principles to determine in terms of a, b and x an expression for f dash x. And so, useful to go back to your formula booklet. This is your formula for differentiating from first principles. And so before we even kind of use the formula kind of for real, it's useful if we're just super clear about what f of x is. So this is f of x. It's also helpful if we work out what f of x plus h means. So f of x plus h just means every time we see an x, you replace it with x plus h. So we would therefore get a lots of x plus h squared plus b lots of x plus h, like that. That's what f of x plus h means. So then, when it comes to substituting into this formula, we're going to get f dash of x equals your limit, as h is some really small value that approaches 0, is going to equal f of x plus h, which is this, a lots of x plus h squared plus b lots of x plus h, minus, and then we've got to be really careful, this whole thing should be written in a bracket, minus ax squared plus bx. It's important that you put it in a bracket to show that the entire thing is being subtracted. Once it looks like that, it makes sense to sort of expand out and sort out the top of this a little bit. And so when we do that, right, I'm going to do this in probably slightly fewer steps than I might do for my, if I was writing this out for the first time, but I think we should be fine. So first of all, if we did x plus h squared, you should know that you would get x squared plus 2hx plus h squared. But then being careful, all of these things are getting multiplied by a. So we get ax squared plus 2ahx. Let's just rub that out. And then here, h squared is also getting multiplied by a. And so therefore we get a h squared. Then we get plus bx plus bh. And then we get minus ax squared minus bx. And that is still all over h. Now, once it looks like that, some of these things are going to cancel. And so this ax squared minus ax squared cancels quite nicely. What else have we got? We've got bx here, this bx here are going to cancel quite nicely. So if we rewrite what we've got now. So on the top, we've got 2ahx plus ah squared plus b lots of h all over h, like this. So then, what in effect can happen is that like an h can kind of cancel from each of these things, because we've got h here, that goes there, h here, that goes there, h here, that goes there. And so then the final thing we're going to want to do is to write out really explicitly, because what we've got is we've got our limit as h goes to 0 is now being written as, let's just get rid of that line, is now being written as 2ax plus ah plus b, like that. And so finally, as h goes towards 0, so as h is getting really, really close to 0, ah will go to 0 as well. Therefore, our derivative, f dash x, is going to be 2ax plus b. And that makes sense, right? If you just go back to the original thing and think, how would I differentiate that normally? You do get 2ax plus b, as the fact that we've got 2ax plus b here is what you're expecting. Okay, so for this question, you're told that the diagram shows the quadratic curve, a and b are constants, fine. Then the shaded region is enclosed by the curve, the x-axis, and the lines x equals 1 and x equals 4. We're also told down here that the area of the shaded region is 9 units squared. Now, because we're told the area is 9 units, the bit of maths that applies to area underneath curves is integration. And so therefore, it makes sense that we're going to need to integrate to find the area. So that's what I'm going to do. I'm going to integrate ax squared plus bx with respect to x, and then my limits that I'm going to use here are going to be 4 and 1. So 4 and 1. So when I actually integrate that, then what am I going to get? Well, I'm going to get ax cubed, because you add 1 to the power, over 3 plus bx squared, because you add 1 to the power, over 2. There's no plus c because we're integrating between limits, and then we substitute in 1 and substitute in 4, like that. Then, when I substitute 4 into this expression, so we're substituting in x equals 4. So what are we going to get? So we're going to get 4 cubed divided by 3, which gives us 64 over 3a, like that. And if we substitute in x still being 4, we get 16b over 2, which is 8b. So that's what we get when we substitute in 4. When we substitute in 1, we are going to get the following. We're going to get a over 3 plus b over 2. And we know, because of how integrating works, that when you're integrating between them, it's you subtract, and that gives you the area. In this case, the area is 9, so I'm going to write equals 9. I can simplify this somewhat. The way I can simplify this, use your calculator, of course, 64 over 3, a minus 1/3 a, or a over 3, is 63 over 3a, which is the same as 21a. And then 8b minus b over 2 is 15 over 2b, and this equals 9. This is good, but this is not enough information to do anything else with, because we've got 2 unknowns in that equation. And so to solve an equation with 2 unknowns, you need another equation to solve simultaneously. So we'll almost put that to one side for the moment and return to the question. What else are we told? We are told that the gradient of the tangent is minus 3/4. So we're told the gradient of the tangent is minus 3/4. When you're talking about gradients of curves, the gradient of the tangent to the curve, this means we need to differentiate. So that's what we can do now. So we have got y equals ax squared plus bx. When we differentiate that to get your gradient function, when we differentiate that, we're going to get 2ax plus b. So this is my gradient function. Now in this case, the gradient function is going to be minus 3/4, like this. So we know in this case that 2ax plus b equals minus 3/4. You might think that's not enough information to solve it. However, there's something else we can do. And we know that the gradient is this. At this point, x equals 4. So what we'll do is we'll say that x equals 4. If x equals 4, then we would get 8a plus b equals minus 3/4, like this. And so what we've got now is we've got 2 equations that we can solve simultaneously. And you can use the you can use the simultaneous equation in your calculator to solve those. So let's try solving those now. So 21a, 15 over 2b equals 9. And then we've got 8a and 1b is minus 3/4. So when you do that, so when you substitute those in and solve them using your calculator, you should get that a is minus 3/8, and then you should get that b is 9 over 4. So a is minus 3/8 and b is 9 over 4. Now I'm going to go on to the next slide just because otherwise I'm running out of space. Okay, so given that we've now worked out what a and b must be, we now know that the equation of our curve is y equals, a is minus 3/8, so minus 3/8 x squared plus 9 over 4x, like that. We are told that this tangent, we were told that this let's just see what we're told now. Let me just reread this. So we're told the tangent to the curve at the point x equals 4 intersects the x-axis at the point with coordinates k equals 0. So it makes sense that we need to find the equation of a tangent. Now a tangent is a straight line. The equation of any straight line is given by y minus y1 equals mx minus x1, like this. So with that, the bits of this that we know, we've got, it's going to be y minus, we'll leave that blank for the moment. We know the gradient is minus 3/4, and it's going to be x minus, and it's this point just here that we know the x coordinate is 4. So x minus 4. The problem is that we don't know this y coordinate, but we can find that y coordinate reasonably straightforwardly by substituting x equals 4 into this expression up here. So if you substitute x equals 4 into this expression up here, let me just check what you get. We get 3. So x equals 4, y equals 3. So this is 3, this is 3, like that. We can make this slightly easier to look at. If we multiply both sides by 4, we get 4y minus 12. If we expand this bracket, we get minus 3x plus 12, like that. And after that, I might just be tempted to put it all on one side. So we get 4y plus 3x minus 24 equals 0. We know that this crosses the x-axis at the point k0. So therefore, if you substitute y equals 0 into this expression, if you do that, you get 3x minus 24 equals 0. And therefore, x must be 8. And so in this case, k is going to be 8. I know we've written x is 8, but that's because it's the x coordinate. In this case, k will have a value of 8, like so.